This is a video from section 6.4 in a Calculus 2 class. Let's take a look at 21. An aquarium 2 meters long, 1 meter wide, and 1 meter deep is full of water. Find the work needed to pump half of the water out of the aquarium. Okay, so we have a picture of an aquarium. Notice how along the side is 1 meter, so that's 1 meter wide. It's 2 meters long right here and 1 meter deep. Okay, I'm going to place the 0 at the bottom of the aquarium with the positive direction traveling upward. Now, this is how I attack pumping water problems. Notice how in red I have a slice of water. It's a rectangular slice of water. Okay? And what I want to do is I want to find the work required to pump that rectangular slice of water out over the tank. Now, the volume of that slice, now notice it's the area of the base times the thickness. I'm going to call the thickness delta y. Now, the distance from this end to this end is, again, 1 meter. From here to here is 2 meters. So that width doesn't change. And so the volume of the slice is 1 times 2 delta y, which is equal to 2 delta y cubic meters. Mass is density multiplied by volume. So to get the mass, we're going to take the density of water, which is 1,000 kilograms per cubic meter, and we're going to multiply by 2 delta y cubic meters. So notice how the cubic meters cancel, and the mass ends up being 2,000 delta y kilograms. Now, the force of that slice is the mass times the acceleration due to gravity. The acceleration due to gravity is 9.8 meters per second squared. So I'm going to take 9.8 times 2,000 delta y, which is 19,600 delta y. Okay, so now we have the force of that slice. Now, let's take a look at the distance that that slice moves. The distance from that slice to the bottom of the aquarium is y. So the distance that that water is traveling to get out over the top of the aquarium will then be 1 minus y. Now remember, we're trying to pump half the water. And so from here, we're going to go from 1/2 up to 1. At the top of the aquarium is 1, and halfway down is a half, right? So the work is the integral from 1/2 to 1 of 19,600 times 1 minus y dy. Well, that's 19,600 times y minus 1/2 y squared evaluated from 1/2 to 1. So this is 19,600 times the quantity 1 minus a half minus the quantity 1/2 minus an eighth, which ends up being 2,450, and we call that joules when we're all said and done. And so that'll conclude this video for section 6.4, and we did problem number 21. And by the way, I have another video where I worked on problem 19, and I did it a bit differently than I did in class. Both methods are correct. Okay, thank you.